Hey everyone, welcome to this crash course on the Agent Development Kit. Google are going all in on AI, and a big part of what they've been pushing for is the agent-to-agent protocol, or A2A. And this enables your agents to interoperate with one another. So in today's crash course, we will be building a multi-agent system that will connect to Notion and ElevenLabs via MCP. Alright, so this is what we'll be building today. I have a Notion page here that has a bunch of sermon notes that I've taken myself, and you can see from the table here, it contains the date of the service, the series, as well as the speaker. And the idea here is that we have one agent that is going to be able to read all of this data off Notion, and we can reason about things within it. The other agent that we'll be using will be connecting to ElevenLabs. For those of you who don't know, it's a really powerful tool, but the main thing that it does really well is that it converts text to speech. And so the best way to demonstrate this is just going as follows. Hello, what are you able to do? It says I'm a master orchestrator. I can delegate tasks to Notion or my ElevenLabs agent. And I can actually ask it some pretty complex queries. For example, I can say search Notion workspace for sermon notes and give me a distribution of number of sermons delivered by speaker. All right, so what it's going to have to do is that it's going to have to reason about how to use the Notion agent in a way that is then going to get the information out of it, and then it has to also then reason about how to present the data back to me as the user, right? Here's the distribution of the sermons by speaker, and it's actually broken it down correctly. Now, the other thing you can do here is, because this is a multi-agent system, you can say, please give me a summary of the distribution and narrate it back to me in speech like a newscaster. And so now with the same agent, we are going to be asking it to kind of summarize this table or this list that we have here in a narration style back to us. And so it's actually finished it now. So let's actually just take a listen of it here.
And now for the latest results. Paul Williams with 4 points. Phil Hudson takes the lead with 9 points. William Taylor follows with 7 points. Willem Davies comes in strong with 8 points. George Dewakar with 2 points. Henry Etok Taylor with 1 point. And finally, we have 22 points from unidentified participants. Back to you in the studio.
Great. And as you listen to that, he actually delivered the news back to us using voice in the style of a newscaster. So this is a very powerful architecture that we are going to be building today. And the source code for this entire tutorial is available completely on GitHub. You can start off with the lesson start branch and follow along from the very beginning, and even the whole completed fully implemented system is available here as well. So you should be able to take this and have everything you need to run it and replicate everything that I'm showing you here. This video is an all-encompassing, self-contained crash course. You don't have to rely on knowledge or information from any of the previous videos. Now, if you're interested in some additional material that will help to solidify your understanding and help you build agents faster, I'm actually releasing an extended version of this repository that contains some additional resources. This build pack is completely optional, and there's a link to it in the description below. And if you haven't already joined my AI-oriented insiders list, you might want to do so, because it's over here where I actually post certain announcements and updates and some early previews of upcoming lessons. It's completely free to join, and for all members of the insiders group, you would have already received a discount code in your mailboxes that will allow you to claim the builder pack that I mentioned completely free of charge. So definitely check your mailboxes for that. I do hope these resources will help to accelerate your AI development. All right, without further ado, let's get going with today's crash course. The first thing we'll do is to clone the repositories here. And what I'm going to do is I'm going to change the folder, put it into the directory, and then I'm going to do cursor dot. And this should open it up within cursor, as you can see over here. The first thing is to check what Python version you have. You can do that by typing python -- version, and you want to be using 3.13 or higher. And it's really important because Google's A2A SDK only works with Python 3.13 or higher. And I found this out the hard way. I actually spent ages trying to figure out why my implementation wasn't working for, I think, almost 2 weeks. And that's what delayed episode 5 a little bit. What we're going to do next is to create a virtual environment for our project today. And the reason is that we're going to be installing all of these dependencies, and we want to make sure that we don't accidentally install it into our entire system like Python, because that actually can cause conflict. So we just want to isolate all of the dependencies just for this crash course. So once you've created a virtual environment, you need to activate it. So you do source.vn, then activate. And you should see this show up in your terminal. And the other way to guarantee that you're using the right version is to do rich Python, and you should see that this should point to the virtual environment that's in the folder of the repository that you just cloned. Okay, as you can see, these are the dependencies we'll be using. Make sure that you're using the exact versions that we have here, because the Google ADK and A2A are developing quite rapidly by Google. And they are actually making quite a few changes. And sometimes just a few versions differences can actually result in quite different behavior. I've actually pinned all the versions that I'm using here, and I've tested it. So if you want to make sure that you do not encounter any strange issues or incompatibilities while you follow along with today's tutorial, you want to make sure you're using these exact versions. And the way you do that is that you do pip install -r requirements.txt. And this will now install all of these dependencies into that virtual environment that you have there. And then it will ensure that everything that we do today, you should be able to replicate it one for one when you go about doing this tutorial as well. Okay, we'll just wait for this to finish installing. Now, while we're at it, it's probably worthwhile just highlighting some key dependencies that we're using. So we're obviously using the Google ADK, which is our agent development kit. We're using 1.2.1, which at the time of recording, I believe is the latest version. We're using the A2A SDK, and this is part of the reason why we're doing this crash course today, is that we're actually going to conform to serving our agents via Google's A2A protocol. In my previous tutorials, in order to adhere to the A2A protocol, we were doing it manually. And the feedback is that while you can actually try to follow the A2A protocol manually, you can sometimes end up missing a naming convention or missing an endpoint, and that causes you to diverge from the protocol. And so the much easier thing to do is actually use what Google has, and this will ensure that when you serve your agents, they will adhere perfectly or as close as possible to perfect for your agent. So it's really important. And then the other thing to point out is that we'll be using LLM. And the reason for this is that we'll actually be using two different models today. We'll be using Gemini. We'll also be using Claude. And the reason for that is twofold. First of all, it's pretty cool to be able to show how you can mix models in your agents. But the other reason is that there is actually a bug in Gemini when dealing with one of the MCP servers. And this will be quite clear soon. So it's quite important that you have LLM installed. All right, so I'm going to introduce the first AI agent that we'll be building today. So the first agent we'll be building today is a Notion agent, which is going to be able to access your Notion pages and any databases that you have and reason about it. So here's an example of a Notion page. This is actually my personal page, and you can see this contains sermon notes, which I usually take whenever I attend service on a Sunday. And as part of this, you can see that we have individual pages for the sermons, and it contains the reading that we have, and then the notes that I usually take based on what's being preached. For each of these entries and these pages, we have a series, we have a date, and then we have a speaker. And the idea here is that I want to be able to have an agent that's able to read all this information, and then I can use AI to ask questions about this data and then reason about this. And of course, if you're using any AI or any LLM, whether it's ChatGPT or Claude, it's not going to be able to have any idea about this private database of yours or this private Notion page. And the only way that you're going to be able to provide access to information from external sources such as this is through an MCP server. And so today we'll be using the Notion MCP server, which we'll have here. And this MCP server is the official MCP server that's provided by Notion. It allows you to connect any LLM or agent to a Notion page of your choice. And that allows you to make use of AI to reason about your Notion pages. And the setup is actually pretty simple. What we want to do, first of all, is that you want to go to this link over here and create an integration. And I'll just show you right here what happens. I've already created an integration here called AI-oriented ADK MCP, which is what I'm using for this tutorial today. And what you will have here is that as you create it, you want to make sure that you do read content. You can do update and insert content if you would like to enable your MCP server and your agent to be able to add a comment or make edits. But for the purpose of today's tutorial, I will only be using the read content, but feel free to check all these boxes. The main thing you want to grab from this is going to be the integration secret here, and will be your API key to be able to access Notion. All right, so let's get back into the code to see how we're going to be able to implement this. Now that we know what we are going to be building for our agent, I also wanted to take this chance to introduce the kind of building blocks of how we're going to construct our agents today. I'm going to use this cheat sheet, which I prepared for today's lesson. And I'm going to just open up the preview here. This will hopefully help to explain some of the concepts in a little bit more detail. I got feedback from some of you that sometimes I go through the how you do it, but not the why. So hopefully this will help to provide some orientation towards what we're building today. And this cheat sheet is going to be made available as part of the Builder Pack, which I mentioned earlier in the video. So what I wanted to talk about today is that for each agent that we built today, we're going to break it out into two parts. We're going to implement ADK version of the agent. All right. So we're going to be implementing our agent with the ADK. And effectively, what it'll do, first of all, is that once we've done it, we will be able to use ADK run or ADK web as you would expect to interact with the agent. And there are only two files that you need to do here. That's just init and then the agent.py. And this is what you've probably seen in other videos about how to create agents using the ADK. But what we'll be doing differently today is that we're going to be also creating two additional files, one with main and one with agent executor. And these are going to be making use of the A2A SDK so that it enables your agent to not be accessed just by the ADK run or ADK web, but rather it will expose your agent by an endpoint. So an example of endpoint is that if you actually look into your env file here, is that it can be exposed on your web server or localhost together with a port, and you'll be able to allow any application, whether it's an agent or front-end application, to interact with your agent. And that's the whole power of the A2A protocol, is that you're actually not just making your agent available via an endpoint, but it's also going to make sure that it's discoverable. Agents will know what it's capable of. It'll know how to make use of the tools that it provides. It's meant to actually standardize how agents talk to each other. So first of all, we're going to be defining and creating our agents as you would with the ADK, and then we'll be testing it with ADK run to make sure it works. And then after that, we'll be using the A2A Python SDK to expose it as an endpoint so that you can use any client to be able to interact with it. And it's very simple. And you will see that once you've understood this concept, this anatomy of an ADK agent, you will be able to easily convert any agents that you have for the ADK to make it A2A compatible. One of the things that we also need to remember to do is to make a copy of this .env.example file and just paste it here, rename it to just .env without the example behind it. And you want to actually add all of your keys that you have for the Google API key, ElevenLabs API key, the Notion API key, and an Anthropic API key. And the reason why we are going to have to use Anthropic here is that, as I mentioned, we'll be using Claude to interact with one of our agents, and then we'll be using Google Gemini to interact with another one of our agents. The ElevenLabs API key and the Notion API key are obviously so that we can interact with those services as well. All right, so let's get going. So the first thing you want to do is create a folder, and we want to name this the Notion Agent. And as I mentioned, the thing we want to do is create the agent and then create the initialization. All right, so we'll create agent.py. And then the other thing you want to do is create prompt.py, because I want to actually put the prompt within here so it's very clear. And then the last thing I want to create is init.py. So you have these three files. Let's get init.py out of the way right off the bat. All you have to do is just to do from dot reports agent. And that's okay to do for init.py. The reason why you need this is because this is how the ADK run and ADK web discover these as your agents. Okay, so that one's done pretty quick. And what I'm going to do is I'm actually going to show you the prompt for the Notion agent. Call it Notion prompt. All right. And I'm going to give you the entire prompt that we'll be using today. It just follows a very standard format for how you want to prompt agents, right? You want to say what kind of agent it is. So a Notion information retrieval agent that will help users to search for stuff. And the goal is to efficiently find and present the most relevant information from a user's social workspace, like from my workspace server notes earlier. There are a bunch of extra rules that I've put in here. This helps to guide the agent to know how to use the Notion MCP a little bit better. This is something that you continue to iterate upon as you make use of your agents, as they make use of the MCP servers. I'll give you a really good example. If you ask the Notion MCP to search for a server nodes database, for example, and then after that you ask it to retrieve information about it, sometimes it will say, I need the database ID. But it's actually, the funny thing is that when it does the search, it actually gets the URL of the database with the database ID at the back of it. So I've added this instruction where once it finds it, it will just extract the ID by itself, and then it can use that ID to perform the second query without having to ask the user to do. So the general practice that you have is that this is stuff that you usually continue to iterate upon as you use your agent more. Okay, so now there's two files down. All we need to do now is create the actual agent. And the way that we'll be doing, first of all, is as usual, we'll just add in a bunch of imports that we're using today. And then we will actually just start off with creating the agent. So we do define create Notion agent. All right. And this will return us an agent. And this is something that I like to do. Whenever I'm working in Python, I really like to ensure that we specify both like the type parameters and the return type as well. A lot of times in Python, even in some popular libraries, you actually realize they don't specify that and it can really trip you up. And so it's quite important. At least I like to do it. And then at the bottom, we just have to remember to do root agent equals to create Notion agent. So this is the framework that should be actually very familiar to most of the people with the ADK. You need to do this so that when you run ADK run, it's able to pick up this agent. And you will actually look for something called root agent, and you just have to make sure that you have this import in your init file. So that's really important. All right, and we'll do the same thing later for the ElevenLabs agent. So I'm going to say that all we're going to do is actually quite funny, but it's actually auto-completed the code that we're writing today. And that's the beauty of using Cursor or any one of these AI code editors. It's pretty smart. So I'm just going to double check, but it's true. So we're going to do Notion Agent MCP is the name. We're going to use Gemini 2.0 Flash, which is going to be fast and cheap. And then it's just a specialized agent for retrieving information. And the prompt is going to be imported from the prompt that we defined earlier. The file is really nice to have your prompt in a different file because you can just modify the spec quickly. You don't have to search within the agent code for it. And here's the important bit. And I'm just going to format this a little bit nicer. Okay, so the only tool that this agent needs is really the MCP server. And you can actually use something called the MCP toolset that comes from the ADK itself. And then you just pass in the parameters that you would do for any remote MCP server. So npx, the MCP server, and then right here, you have to follow what the guide tells you. You don't just pass in Notion API key and then the key, which is what a lot of them do. You actually have to format it in this way. You have to do it as Open API, not OpenAI, Open API MCP headers. And then you do it in this way, where you do authorization and then bearer, and then you put the Notion API key within that, and then you specify the Notion version, which is this. And that's how you specify it for this server. As you see later for the ElevenLabs agent and the MCP server, you actually specify it differently. And what you need to do is always check the official guides on how you specify the authorization token or the API key. And that's pretty much it. And the beauty of this is that you don't need to really look into every single API that has been exposed by Notion anymore. You just specify one MCP server, it'll figure out which tools to use. And if you're new to MCP or you've been trying to figure out what's the point of having an MCP server, this is the point. You do not need to use an API. You do not even need to use the official API. You don't need to use an API and figure out all the different endpoints that you have to read and all the different kind of parameters that you have to pass. You use natural language, and then you ask questions, and it's just going to figure it out by itself. And we're pretty much done with the ADK version of this. And so I'm just going to drag this over here one more time. So we've actually done all of this, right? So we've done the agent.py, init.py, and I'm missing prompt.py here, but really it's just part of agent.py. And then we should be able to run ADK run or web against it. And yeah, let's just give it a roll right now. So let's open our terminal. And what we do here, it's just the ADK run, Notion, freedom. And this should just use the ADK and allow us to connect to our agent, and we should be able to ask it various questions. All right, so here we go. Let's try this now. It's like, hello, how are you? What can you do? We just want to make sure the ADK is working, the LLM is working, and the keys are correctly configured. All right, you can say I can find any information on my Notion workspace. So I can say here, all right, so, search Notion or summon notes and tell me the total number of summons there are. And off it's going to go to do its thing. And you will probably see this error. And here it's going to say something where it says timed out while waiting for response to client request, waited 5 seconds. All right. Now here's the problem. So this is actually a known issue. As part of upgrading to 1.2.1, they've actually hard-coded a 5-second timeout when connecting to MCP servers. And this is a problem because in a lot of cases, you need a little bit more than 5 seconds in order to be able to connect to an MCP server. And this is not configurable for now. I think they're going to make it possible to do so in the future. So a really helpful member on the Google ADK GitHub page has actually created a workaround, and I've included this as part of the repository, and it's called a custom ADK patch. And this custom ADK patch actually increases timeout to 3 minutes and allows you to configure it. And this is going to be quite important to use this in order to follow along with the tutorial, because this will then actually allow you to not encounter this error. So rather than using MCP toolset, do custom MCP toolset, and then you want to do from utils, custom ADK patches, custom MCP toolset. All right. And yeah, so now if you actually try it again, it should work fine inside. You need to be able to do that in order to avoid this timeout error. And this is a part and parcel of working on the bleeding edge of technology. Sometimes as things move fast, things break, you're going to need to be able to navigate these challenges. So anyway, let's try it again. I'm just going to straight prompt it, right? Check Notion for sermon notes database and tell me how many sermons there are. All right. You can see here it's actually apply custom timeout. So do you know that our custom ADK is definitely working? And here we go. And we see it actually responded. All right. So it's working, right? So I found a database called sermon notes. Here's the information. And then that comes with the URL. And you see, it actually passed the URL here. And if we didn't have this prompt here, which says extract and use the ID, what it will actually do is that it will actually say, can you give me the database ID? But because we have this here, it's actually going to be able to do it itself. So I need to query the database. It will be able to figure this out by itself. And then it says, based on the query, there's 65 sermons in the sermon notes database. So there you have it. It's definitely working. You can actually run this with ADK Web as well, and this should work exactly the same. I like to do it in the command line because it just allows us to very quickly test that things are working. Okay, so now we're going to be creating the ElevenLabs agent, which is a text-to-speech agent. It's actually pretty cool. It allows you to convert any text into speech, and you can choose different voices and stuff. We're just going to use defaults today. And those of you who are familiar with this series will be very familiar with the ElevenLabs MCP. But the point I'm going to show here is that once you understand the anatomy of the agent, it's pretty much the same. And once you understand how to use MCP tools, it's even easier. I'm going to whiz through this because it's actually going to be pretty much the same. All right. So let's see how quickly we can get this done. So what we do, create new folder. I'll call this ElevenLabs Agent. All right. Create init.py prompt.py agent.py. And that's pretty much it for now. All right. And then let's just keep this cheat sheet over on this side. And like from here, prompt.import agent. So that's done. Boom. I'm going to give it a prompt for the ElevenLabs one. So the ElevenLabs prompt is that you are a text-to-speech agent, convert user text to speech audio files. And then one thing that I've done is that I've made it specify it in a very specific way. The audio file is saved at this path so that you don't have to query it again. So sometimes the ElevenLabs agent says, I've converted it, and you'll be like, where's it? And then you have to say, can you please give me the file path? And then it gives it to you. So very similar to the Notion agent, just adding some rules to the prompt to give you what you want. Okay. And then for the agent, oh, sorry, I put this in the wrong file. So this should go into prompt.py. And then in the agent file, I'm just going to use the same imports as previously. All right. And it's going to complain that we haven't used any of these, so that's fine. And then what we do here is we do define create ElevenLabs agent. Right, and then remember root agent equals to create ElevenLabs agent. And so what I'm going to do is that I'm just going to directly paste this right in here. Right, so and the agent, and then I'm going to use custom MCP toolset so that we don't get restricted by the 5-second delay. We just use UBX and then ElevenLabs MCP. And then in this case, it's a lot easier. You don't have to do the whole headers thing that we saw before. We just do ElevenLabs API key, and then you pass in your ElevenLabs API key. And that's pretty much it. There is a config file in which I actually import all of the API keys and stuff so that you don't have to keep doing os.getEnv and things like that. It's just a nice pattern to know where all your API keys and stuff, so you don't have to keep doing all this strange logic. Okay, so that's actually that. Now, I told you this was fast. We're actually ready to give this a roll. And maybe this time we'll do it with ADK Web. So the way you do it, let's open this up and you do ADK Web. And then once it loads up, you can just open this up in your browser and we can give this a roll. Oh, and one quick thing before I forget. You might remember, if you actually look at how we are specifying the models here, we are actually using light LLM as opposed to using Gemini. And you can see the way that we specified the model was just specifying Gemini 2.0 Flash here. But then here we are actually going to be using Claude Sonnet as our model. And in order to do so, we make use of the light LLM library. So this is actually a really good library. You can use it to pretty much specify any model that you want, whether it's from OpenAI, whether it's Claude, or even some Gemini models as well. And the real reason why we need to do this here is that is a bug with the ADK in 1.2, whereby it doesn't play very nicely with the ElevenLabs MCP server. Something to do with the schema generation and it not matching. So it's quite strict, the Gemini models, and I think for that reason it fails. So in order for it to work and for you to be able to use the ElevenLabs Agent MCP server on ADK 1.2, you're going to have to use an anthropic model. So this is how you do it. It's very easy. You just pretty much just change one line and just use the LLM version. So just wanted to call that out. All right, so while I have my browser open, I thought I'd do a really quick overview of how you get your API keys from ElevenLabs. So once you sign up or logged in, just go to this bottom left corner over here. I click on it and just go to API keys. It's pretty standard, all of these services, how you do that. And then you just do create the API key, type in whatever name you want. And then once you created it, it should give you the API key that you need to be able to pop into your ELD file. All right, so let's switch over to the ADK web view. We've got our ADK web view over here. So we're gonna like our ElevenLabs agent, and I'm gonna do, hey, what are you capable of? And it's gonna do it thinking, and sometimes this takes a little bit more than 5 seconds. And this is the reason why doing that patch that I talked about is quite important, because when you're working with MCP servers, oftentimes it takes a little bit more than 5 seconds, at least the first time around. So remember to make that patch. And now it's responded, and the agent using the MCP server says it's capable of all of these things: text-to-speech, phone call capabilities, voice design. And that's great, right? Because if you had to use the ElevenLabs API directly, for you to be able to determine that it's capable of all these things, you probably would have had to, I don't know, look at the docs or check the API itself. And I think this is the beauty of using an MCP server. You can pretty much use natural language to work with like a service. And that's really why when people say that, oh, why using MCP, you can just use an API and API server. And I'll demonstrate to you why this is so important. So I'll say, convert the following: speech, Google, ADK is great. This fresh horse is not too bad either. And off it goes. And this is the beautiful thing about the ADK web interface, and that's the reason why I really liked the ADK itself. If you actually click on this, you can actually see, it actually visualizes for you what the MCP server is capable of. And you can see these are all the tools that it has, not just converting text to speech, but it has like creating like an agent and adding knowledge bases and all, make an outbound call, all this stuff. And for you to be able to actually know all this, you would actually have had to look at the API itself. And not only that, all we did here, right, is that we just said convert the following to speech, to very natural language, and it was able to figure out which tool to use. And that's very powerful. You didn't have to think about which format to pass this line in, and that's the power of using LLMs together with MCP servers, able to make it much easier to interface with a service. And what's more, with the ADK web interface, if you haven't actually played around with it, you can really get a lot of information for debugging purposes or just for learning purposes. You can see the prompt of our agent over here. And then actually, if you step through, you can actually see lots and lots more of how the MCP server is actually set up and how it exposes the different tools and the kind of prompts that it has. And it's pretty cool, right? And then finally, you can see the response here. But this is what we've actually decided that we wanted to convert. And it's actually done it already. We're going to pop this over here. And then let's play it.
The Google ADK is great. This crash course is not too bad either.
Perfect. All right, and we've got it working. And I told you, it's just a couple of lines of code. All we had to do really was to actually just change which MCP server we were using, change the prompt, and in our case, we just changed which model we were choosing to use over here. And that was all we needed to do to be able to get an agent that is now fully capable of doing anything that you want to do with ElevenLabs. So what we're going to do next is that we're going to expose these two agents in a way that they are actually accessible by endpoints, and we'll make sure that these endpoints are A2A protocol compatible. And the whole point of doing so is so that we can actually then interface with our agents without having to use the ADK web or ADK run. We can actually expose these agents by endpoints so that you can connect any front end or any other agents to be able to connect with it. And all will be a lot clearer soon. So let's switch back to Cursor. All right, so now that we're back in Cursor, what we're going to do is, let me just pull up this cheat sheet for a second. So it helps to explain a little bit about what we're going to be doing next. All right, what exactly we're going to be doing here is the following. Remember, what we did previously was to enable our agents to be able to be run with ADK run or ADK web. So we've done that for both our Notion and ElevenLabs Agent. And now what we're going to do is that we're actually going to add the required components in order for us to expose our agent to a regular HTTP client. So an HTTP client would be able to do things like post or get against our endpoints of our agents, and then our agents will then be able to perform whatever task. Now, this is really important for one simple reason, is that if you use ADK run or web, you wouldn't be able to create your own front end in order to interact with your agent. However, if you expose it by an endpoint, then you'll be able to actually use your favorite front-end system, whether it's TypeScript or React or Next.js, or you can actually use a Pythonic one, which we'll be using this time, like Streamlit or Radio. And this will allow you to be able to interact with your agents and then using the response and render it in whatever way you want. I actually did a tutorial on this, the 2 ways. One of it was using the ADK's API server, which exposes the endpoints for you. But today we're actually doing another one where I show you how to actually just run it like you would for a regular fast API server. And that actually gives you a lot more control over what endpoints you expose. Now, today what we'll be doing is that we'll be using the Google A2A library to be able to expose our agent. And you can actually see it over here, right? It's the A2A SDK. And what this does is that it actually not only exposes your agent to be able to be accessed by an HTTP client, but it exposes it in such a way that it's A2A protocol compliant. And this is a standard protocol that Google is pushing, is being adopted by a lot of people. And this ensures that when they interact with your agents, there's a standard set of endpoints that they will know exist. They'll be able to understand what your agent is capable of. They'll be able to understand how to interact with your agent. And ultimately, the whole point of having a protocol, just like the Model Context Protocol or MCP, is so that you can standardize it. And what they're trying to do is so that in the future, you can have lots of different agents and they can all interact with each other, and you wouldn't have to worry about whether they're implemented one way or the other. It's all going to be standardized, and that's the power of the A2A protocol. And by using the A2A SDK today, it's going to actually make exposing these endpoints that are A2A compliant a lot easier. All right, and I'll show you how it's going to be done today. Because in one of my previous tutorials, in fact, in episode 4 of my ADK Made Simple series, we actually started to make it A2A compliant. What you actually realize is that in order to make it A2A compliant, there's actually quite a lot of things that you need to follow according to the protocol, whereas this one actually does it automatically for you. So now that we've understood the overall anatomy of the agent, let's go ahead and implement it in code. So the first 2 things that we are actually going to need are the main.py file and the agent executor. So I'm going to create both of them right now. So first of all, UI, and then I'll call it agent executor UI. Cool. And the great thing about this is that once you've written it once for one agent, it's actually very similar, and you pretty much just can copy and paste it for the second agent as well. So I'm just going to prepare it by copying the files over, because these are the 2 files that the agent is going to need as well. And probably we'll keep this cheat sheet so that we have this at the back of our hands if we need it. And so we'll start off with doing the agent executor skeleton code. Then we'll do the main entry point, and then we'll flash this one out. So that's how we're going to go about doing it. And we'll start off with the Notion agent. And then you will see that when it comes to doing it for the ElevenLabs agent, it's going to be pretty much the same. Okay, so let's begin with the agent executor. So the very first thing I'm going to do is just add in a whole bunch of imports. And you don't have to worry about all these squiggly lines at this stage, because we will end up using it within the code once we're done. The thing that I like to do is always have a logger. So we set up our logger. It really helps us when you need to debug through the application. We're going to call this the Notion ADK Agent Executor. And you can see that it inherits from Agent Executor that comes from the A2A SDK. Great. And then within this, we are actually going to create just the skeleton of the code. So we're going to have a constructor. And what this constructor is going to do is it's going to take an agent from the ADK, something called an agent card, which effectively is going to determine what the agent is capable of. And then finally, a runner. The runner is effectively the thing that enables the agent to continuously process and deal with the requests. And more will become clear soon once we flesh this out. The only 2 methods that we need after this, at least at a high level, are execute. And it's going to take a self, the context. The context here comes from something called the request context, also from the A2A SDK, and this contains everything that you need to handle the requests. And this event queue here is how you actually deal with sending the responses back to the client. All right, and the return type of this is none. And I really like to be quite explicit over the types of the parameters that are passed into the functions, as well as the return types of the functions themselves. It really helps, and I know Python allows you to get away without specifying it, but the reason why this is useful is that if you're working with AI agents like Cursor and Windsurf or any other AI agents, these type signatures really help to reduce mistakes. The third function here is actually going to be very similar. It's actually just going to be cancel, and this deals with canceling requests coming from the client. What I'd like to do is actually also add some commas behind here, so we actually are able to see it in a slightly nicer manner, and then we'll begin implementing the rest of this very shortly. All right, I just realized that I've actually done this wrongly. This is within the ElevenLabs agent. I just need to rename this to the ElevenLabs ADK Agent Executor. And you can see it doesn't really matter because it's going to have the exact same framework below. And so we will continue to flesh this out later, but let's do the main entry point into our application. And if you look back at this diagram here, the entry point is really going to be dealing with the request that comes from the client, and it's usually HTTP request. So the main thing that this is going to be focused around is going to set up a server that's running and runs in a loop, and then it handles the request and passes it on to the agent executor. So in the main function, we're just going to do the same thing that we usually do, which is add in a whole bunch of imports. And the two key imports that you're going to need now are the agent executor, as well as a way to access the brain. Okay, so the only other two main imports that you need here are to import the ElevenLabs Agent Executor that we just defined, and then we need to put in the ElevenLabs Agent, and you want to be able to create the ElevenLabs Agent, which is defined in agent.py that we did earlier in the tutorial. Okay, so that's pretty much all we need to do. What I also like to do is make sure that we have our logging set up once again. So what we're going to be doing is defining a main function that takes in a host and a port. And I'm using something called click, which allows you to very easily specify the host and the port by the command line if you need to and set a bunch of defaults. So that's what these things are doing over here. You just want to make sure that the ElevenLabs API key is set before running anything within this main function. So it's almost like a bit of a failsafe. And the next thing that we're going to do is something called the agent card. Now, the agent card is effectively how the agent broadcasts its skills and its capabilities to everyone using the A2A protocol. All right. And you might have seen this in another tutorial of mine or in other people's tutorials where you have a .well-known /agent.json and then you specify it there. But what I've seen is that it's actually better to specify it in code because it provides you with the ability to do something like specifying dynamic parameters and perhaps also having skills that are dynamically generated. This is the pattern that I've seen, so that's what we're going to be doing here. All right, so the skill of the agent is very simple. It's going to convert text to speech, and then it takes input text and returns an audio file. And then the agent card is effectively just the name of the agent, brief description, how you access it, and the inputs are text. The outputs can be text and audio. And then the capabilities, we're just setting streaming to false and push notifications to false now. And then we're referencing the agent skill that we have over here. It's worthwhile noting that if you recall, our ElevenLabs agent and MCP server is actually capable of doing a lot more things, right? It was not just text to speech. Remember, there was a lot of other capabilities as part of the MCP server that it was able to do. However, we want to focus our agent only on text to speech. So this is why we are constraining it over here. And that's the power of the A2A protocol. You're choosing what you want to broadcast as capabilities of the system, of your agent, and then you can hide the implementation details. So you can swap it out with different MCP service if you want. Maybe in the future, you want to change out ElevenLabs. You can just call this the speaker agent, and then you can just swap out the MCP server, but you know that it's going to still focus on just text to speech. So this agent card has been done. And then the next thing you want to do is that you want to create the agent. So you do create the ElevenLabs agent. And then you set up the runner here. The runner, it takes in the following parameters: the agent, which in this case is the agent that we've just created, the app name. We are actually going to use what we've defined in the agent card so that we can keep things consistent. And then we are going to then set the three services, which is the artifact service, the session service, and the memory service. And these are the things that are quite important for your agent to be able to maintain context between different conversations that are going on, and so that it doesn't have amnesia. Okay? And then finally, once you've done that, you set up the handler. All right, so now you've got your agent and your runner that will run the agent. You just need to be able to handle requests that are coming in, right? So as you can see here, there are going to be requests coming in from outside. You're going to be handling requests that are coming in by HTTP. So we create a request handler. Okay, and we can just use a default request handler. And all it does here is that it takes in an agent executor, which, all right, and the only thing that it takes in here is actually an agent executor. All right, so now that we've got a runner, the last thing we need to do is actually make sure that we got our agent executor initialized. So we call it agent executor, and you can see it just takes in the agent card and the runner, which we defined in earlier. And then finally, we want to handle the requests that comes in from the HTTP client. So we do request handler, and we can use something called the default request handler, which just takes in the agent executor and then the tasks, something called an in-memory task store. And a lot of these things are all the default. And a lot of these things that we're using, the in-memory service and the session service and the in-memory task store, all come from the A2A SDK, which makes it a lot simpler that rather than you having to define them yourself. And then now that we've got a request handler, we create the app itself. So we call it A2A app. All right, I'm using a Starlet application, which effectively is something like Fast API or Flask, which exposes endpoints. But in this case, because it comes from the A2A SDK, it ensures that the Starlet application really conforms to the A2A protocol. And the only two parameters are the agent card and the HTTP handler, which we have defined over here. And then finally, it's probably worthwhile at this stage to do a bit of logging. So we're just going to broadcast that the ElevenLabs agent has started. And also sometimes really useful to make sure we can see that the skills of the agent card matches what we expect. And then we'll be using UVCon that will allow us to run our app continuously, listening for requests. All right. And finally, we just need to create the entry point to this, and we will do main shell. So now we actually have an entry point built to our system. And the reason why you do it this way is so that we will be able to do something like -m ElevenLabs Agent. And this will allow us to run the ElevenLabs agent by using a UVCon server and serving its endpoints rather than using the ADK web version. So this will allow us to create this rather than using this over here. All right, so now we've defined that, we will just switch over back into fleshing out the agent executor. What I'm going to do actually is that I'm going to actually do the cancel function first because it's actually pretty standard. And I'll just put in the code here and then I'll walk through it. What you want to do here is to get the task and the context so that you know what task to cancel, and then you put in a timestamp, and then you send a cancel status update back to the client via enqueue event. All right, so this is pretty self-explanatory. It's just dealing with canceling requests to the agent. Don't worry about this squiggly line here because we haven't defined the constructor. All right, so let's do the constructor then. Okay, so this is also very straightforward. The main thing that we want to do here is, first of all, I always like to make sure that we log that this is actually happening. We initialize a bunch of instance variables that we will be needing. So the agent card and the runner. So we're storing this from what we get here. And then the only two things that we want to reference as well is making sure that we have access to the runner session service and the artifact service. And you can also deal with the memory service here if you want, but for the purpose of this ElevenLabs agent, we don't really need it. And then we just add one more piece of logging just to make sure that everything looks fine. And let's put vision here. Cool. All right. So now we will move on to the agent executor. And the way I like to think about this agent executor is actually in the following manner. Okay. So really what you're doing in here is that you are doing 4 key steps. All right. So step 1, you want to prepare the user's input for execution with the LLM. Okay. And then the second step that you're going to be doing here is that you want to prepare all session and context related data so that you can maintain any conversations that are going on and you know what you're talking about if you say, hey, continue with the previous task or something like that. All right. And then step 3 here is we are going to send the input to the LLM and loop until a final response is received. And then step 4, we are just going to send the response back to the client. Okay, and that's the easiest way to think about the execute loop. And you might be thinking, why do I need a loop in execute? And I've got this diagram in the cheat sheet over here, which hopefully helps to explain this in a little bit more detail. Okay, so if you look over here, when a client sends a request to the agent, say do something, right? Sometimes the agent will be like, okay, I'm on it. and then it'll send an immediate response. But what it does is that it's going to break down the task, right? And this is where the runner comes into play. So it's going to effectively try to accomplish this thing that you asked it to do in a loop. And sometimes it gives partial responses, sometimes it streams its reasoning, sometimes it's sending like the stream tokens back to you. And this can continue for a while until it's reached a stage where it's done with what it's supposed to be doing, right? So this is the loop here that occurs in step 3. And finally, when you send a response back, you usually wait for something called the final response. So this means that the LLM is done with the task and is ready to return its response back to the user. And once you got the final response, you set the status to complete, and then you send back any artifacts related to serving that. So the artifact could be just text, hey, I've done the task and here it is. Or it could be, here's the audio file that you wanted, or something along those lines. And so once you understand, this is actually very simple. And I won't go into a lot of detail because the main thing to understand over here is what goes on during the executor. Once you get a high-level understanding, that's all you really need to know. And now I'll show you the code. The main thing you want to get out of this is understanding what goes on in the life cycle of a request. Okay, the first thing we're going to do is that we're going to get the user input, and we're going to create a function called prepare input very shortly with the context. And then the next thing we're going to do is that we're going to get the user ID and the session ID. And I'm going to be using something called get session identifiers, which we will define with the context again. And after that, I'm going to do something called ensure ADK session, just to make sure that everything is going according to plan. Okay. And then right here, we're going to be doing something called final message text. And then we'll have a function called run agent and get response. And maybe you should be putting it as run agent in a loop and get response, but it doesn't matter. And it's going to take these 3 things. It's going to use the user input that we get here, the user ID, and the session ID that we determined from the session. Okay. And then finally, we will just, like I said, send a response back to the client. I'll just call it send response. So we will send the, all right. And when we send a response, and finally over here, we are going to send the response back to the client. And the way that we will do it is by taking the final message, the context that was given, and we will send it via the event queue. All right. And the event queue is how it queues up things and packets back to the client. And so what we'll do here is that we'll do self.send response. We will send event queue, context, and then the final message. Thanks. And the only last thing that we want to do is that put this into a try except block. So what I'm going to do is I'm going to do try, and then we're going to pop all these indented, put this into a try except block. All right. And then I'm going to have one more thing called handle error. All right. And I'm going to use the event queue, context, final message text as well. And the reason we try to send a message back via the LLM through the agent back to the user so that they can see what's gone wrong, rather than it just hard crashing or it not completing the request. Okay. All right. So I'm going to now just copy and paste all of the code that we will be needing to define each of these functions over here. I'll just pop it at the bottom, maybe. Yep, is that correct? No, that's not in line. All right, so it's created that for me. All right, here we go. All right, so these are all the functions that we were just talking about. So let me just walk through them very quickly. So you can see prepare input here is that it takes from the context, right? It actually grabs the user input and checks whether there's anything missing, and then it just returns the user input. So nothing too complicated. Session identifiers, again from the context, it gets a session ID, and then it returns that from the context. Or sometimes it has to create a new session ID just to indicate that this is a new session. For the user ID, you will notice that I've actually hard-coded it. And you will see that some people actually set this to self, right? And you might be thinking, wait a minute, does this mean that the agent is going to only run with a single user ID? And the answer is yes. And while it might not make sense at the moment, but think about it, right? Because these agents are going to be dealing with requests from various different clients, right? So you have one client that's sending it to this agent, another one that's sending it to this agent, another one that's sending it to this agent. And the user ID here really isn't as important as the context of the task in question. And it's really all you need to know, because on the front end side, you can ensure that every user has a specific task that's associated with it. And therefore, the agent's only really concerned with dealing with tasks as opposed to thinking about whether this is that user. Obviously, you can extend this to be more explicit about having different users. But for the purpose of this demonstration, we're keeping it a little bit more simple, and you will see that this works for us. All right. So That's the session identifiers. This ensure ADK session is effectively going to make sure that the session service is able to create a session with the user ID and the session ID that we actually did from over here. And like I said, because the session ID already has the context of the task that's in question, you don't really need the user ID here. But if you wanted to, you could actually put it in here when dealing with it. All right. And then here is the run agent and get response loop. The best way to demonstrate this is by this other diagram in the cheat sheet over here. So I'm going to just scroll down and go back to this diagram. Remember, we actually do this looping until it's done, right? Because you send a request, you might have to do a bunch of subtasks within the LLM. It's like, okay, do this, I got to do that, I got to fetch this ID. And then he's got to deal with this in a loop. This is what this code is doing here. All right, you can see here, there's a bunch of events and it's going to just go through the events, but it's going to wait until it gets something called the final response. Because in our agent, we are only concerned with sending back the final response. Once it's done, the conversion to speech, just going to send it back. We don't really care about it thinking about, oh, I'm going to use this voice, I'm going to use that. It doesn't really matter for us. So we only check for whether it's the final response. Once we get it, we break out of the loop, set the final message text and return it back to the client. So this is what really is going on here. So this loop here, you can actually expand it to do more things. Like if you wanted to render thinking or sub steps to the client, you could do it here. But like I said, we try and keep it very simple, getting the framework here in place for you to be able to get to an agent that is working. And then you can expand upon this if you wish. Okay. And then finally, the send response. As you can see, it uses the event queue. And this is how we queues back the responses back to the client. And then we use this method that comes from the SDK called new agent text message. You pass in the message, the context, and the task, and then it knows how to send it back to the right client. So, oh, and the final thing is just handling the error, which we also use a similar method here, but instead of passing in the final response, we catch the error and send it back. All right. So this is actually how you do your agent executor. And let me just see, there's a problem with the linter. Let's see what's going on. Let's see. Oh, forgot that these need to be asynchronous. All right, and what's going on here? Okay, so in this case, we actually do it backwards. All right, because the method signature takes in the error first, then the event queue, and then the context, and nothing to do with the final message. So I made an error here. Just to make things a little bit more consistent, I'll just change this up so that it takes in the event queue first, and then, if I'm not wrong, it takes in the context, and then it takes in the error. Just to keep things consistent with send response. So what we do here is that we do event queue, context, and then pass in the error. That's it. I think this is working now. Cool. All right. So now that we're done with the ElevenLabs agent, what we want to actually do is test it out. And so the way that we test it out is rather than running ADK run or ADK web, we're going to start the server by directly calling the main method as a module. Okay. So let's just clear our console now. And I've got this leftover from before. Okay. And I like to create two consoles over here. You can do this by very easily just console. I just split the terminal like that. It gives you a good way of running a test and then checking the server, or running the server and then running a test. And as part of the repository, you will actually see that I've got something called test client, which I'm going to just paste in here. And I'm going to do the same thing for the Notion agent as well. And what this test client Python file does is that given a URL of the agent, it actually uses something within the A2A SDK called A2A client, get client from agent card URL. So you pass in the agent URL, and then this actually creates a client that will allow you to send requests to. All right, so it's actually pretty nifty. And it's great that the A2A SDK actually does this, because in one of my previous tutorials, we actually wrote the server and we would have had to write the client ourselves to connect to it by A2A. And this handles all the boilerplate for you, so you don't have to worry. Okay, so what this test does, as you can see, is that it just says convert this text to speech, and then we can check the response. And you will see for Notion Agent is that it's just going to do exactly the same thing. It's going to get the URL of the Notion agent, and then it's going to run a bunch of tests where it's going to search and do a database test. And we'll get to that later. Okay, so what we're going to do is that we're going to do Python -m, and then we're going to do 11 agents. And if all looks fine, we will see that it will start serving this on the server on 8002, I think, or 8003. Can't remember. Okay, it's running on 8003. And I just need to make sure that I am actually testing it on 8003. Yes, I am. Okay, and so what we do here is that we run Python ElevenLabs Agent / test line. You don't need a -n here because you're not running it as a module. You're running it as a direct Python script. Okay, so we're running that. You can see it's connecting to the ElevenLabs agent. Connection is successful. You can see that it's created a new ADK session on the server side. And then the query that we're sending is to convert that to speech. And you can see it actually succeeded, right? And you look through the server side logs. You can see it's using Claude 3.5. It's using the MCP server to connect to ElevenLabs. And then it's doing a bit of processing. And then it's the final response is I've converted this. And you can see this here as well. So it's converted the file. And we don't need to test this again. You know that this is working. So now, what have we done here? I'm just going to use the cheat sheet again. What we have done here is effectively allowed us to serve our agent by an endpoint. So any client, whether it's an agent or front-end application, is going to be able to interact with this agent. But the great thing is that if it's an agent, it will know what our agent is capable of because it's A2A compliant. You have an agent card that broadcasts it, and then it connects and sends requests according to the A2A protocol format, which it knows how to deal with because everything has been standardized. And that's the reason why the A2A protocol is so powerful and why it's something that we are emphasizing here. Great. So now you got this, and that's it. And because, like I mentioned before, the framework of defining these things is going to be so similar between the two agents, I'm not going to go into too much detail for the Notion agent because the code is actually going to be pretty much the same. So I'm going to just copy and paste the entire code. It's all in the repository, so you can see it, and then just quickly walk through it. But then you will see that it's very similar to the ElevenLabs agent. All right, so the whole point is to just save us some time here. If you look at the main file, very similar, right? What we do is that we allow it to specify the host and the port. When we start it, we check that it has the API key. We define the agent card. We create the agent, initialize the runner, and then we instantiate the executor. And then we set up the request handler, start the application, just do some logging, and then we start the server. Very similar to what we did before. Okay. And then for the agent executor, you will see that it's actually pretty much the same thing. If you look in the execute function, we just prepare the input, get session identifiers, ensure that it's there, run the agent in loop, and send back the final response. Okay? And so hopefully you've seen that the framework for getting an agent up and running with the A2A protocol is actually very straightforward, and it's actually very similar between agents. You can expand upon this framework to do things that are a little bit more customized. So do let me know if you have any questions or if you'd like to see something a little bit different. But the whole point of this is to just demonstrate how quickly you can get multiple agents doing different things, but effectively being served via the A2A protocol, via an endpoint, in a couple of lines of code that mostly are similar. And so you should be able to just take this pattern and roll it off to your own agent very easily. Like I mentioned, I have already included a test client that will run HTTP requests against your agent. And in this case, it will run two things. It will run a search. So it will search for the sermon notes, and then you will just count the number of entries in the database. Okay? So what we do, again, is we run -m, and in this case, we do Notion Agent, and we'll just wait for it to boot up so that we will be able to confirm the port. So it's on 8002. And now we just run the test. So Python, and then we go Notion Agent, test client. And yeah, you can see it's already connected to the Notion Agent. Send back the agent card. It's running tests. You can see the first task has succeeded. It says, I found a page called sermon template. And then here's the tag sermon. And then it actually says that there are 62 entries in the sermon notes database. And you can see down here that there's a lot more going on in this block here, and it's probably not very readable, but effectively you can see that the Notion MCP server is working fine, and the agent is able to utilize it correctly to respond to our requests. And so that's actually two agents that are running. And I just wanted to call your attention to just one more thing that we've talked about here. Now, what we've done is that we've defined each agent with 4 main files, or 5 if you include the prompt, right? The agent brain, the initialization, the agent executor, and main. But the beauty about doing it this way is that you can run the agent using ADK run or web. So you can test this out very quickly, or you can serve it via the endpoints using the A2A SDK, but you don't have to modify anything else. So if you actually change your agent's prompt, for example, this will automatically be propagated to both when you run it through ADK run or when you run it through the A2A protocol. And I really like this pattern. I think this allows you to really isolate your changes. It allows you to not have to worry about whether you have to update two different places or accidentally breaking one or the other. And I think that this is actually the power of the ADK right here, and also the A2A protocol and the A2A SDK. The way that they've made it run is that you can actually pretty much have the same code base and serve it in two different ways. Okay, so now that we've finished the two agents, the final agent that we'll be doing is something called the coordinator or host agent. And the best way to demonstrate this is in the lesson plan over here. I'm gonna preview this. Okay, if you've looked at any other ADK tutorial, whenever they do multi-agent systems, in fact, I actually have a tutorial, I think, in one of my series on how you can create a multi-agent system. Oftentimes, they just use the sub-agent parameter within the agent constructor. All right. And if you wanted to create an agent in ADK that coordinates between two of them, you can actually just pass them in like that, right? You create the ElevenLabs agent, create a Notion agent, and then you provide some instructions. You probably have to be more detailed than this, but this is the general pattern. Now, the problem with this is that, number one, this assumes that your agents are ADK agents as well. All right. The problem number two, it also means that all of these agents are going to be served on the same machine. And so this means that if you need to scale up the architecture, you can have to scale all three of them together, or rather you have to scale the resources on all of them together. But maybe the agent that takes up the most resources is the Notion agent, right? This is a very tight coupling. It's very good for quick prototyping, I would say, and it's very good if you're planning to have a ADK only architecture. But sometimes you want to be integrating with other agents. And that's the whole reason why we've moved to this A2A architecture for this tutorial. The beauty of it is that rather than directly having this in memory, right, to the two agents, we are actually using the A2A protocol by HTTP calls to interact with the agents. And this means that you can actually swap this out and use some other agent framework. You can be using LangGraph, or maybe you're directly using one of the provider's APIs and wrapping it around. The great thing about using it this way is that you've actually normalized the interaction pattern, because all of them implemented in A2A, you don't actually need to bother. Everything will work correctly. The other good point is that you can actually now scale up the resources of where you host this agent, and then maybe you have a different virtual machine that stores this agent, and you can have the smallest virtual machine for the host agent because maybe this one just does a lot of coordination but not a lot of compute. And so this is a very modern architecture that serves a particular use case, and it's the whole point of this tutorial of highlighting this. So we're actually going to be doing it differently than my previous tutorial or other ADK tutorials. We're not going to use the sub-agents way of doing it. We're actually going to communicate with the two agents via HTTP. So this is what we're going to be doing next. And hopefully this is clear. All right, so let's get started with actually implementing our host agent. And we will effectively be creating it just as we've done the previous agents. So we start off with the 4 files to make sure our host agent conforms to our architecture. And then we will add in the additional functionality for it to be able to interact with the sub-agents via A2A. So we will first create a folder, like host agent, and we'll just create the 4 files as usual. Init, agents, friends, agents, executor. And the 2 extra files that we'll be needing is called tools. And the other one is remote connections. And this is what we will be using to connect to the sub-agents underneath it. Okay, let's do the easiest one first. So this one is going to be just from report agent. Cool. And then let's do the prompt as well. And I'm just going to paste the whole thing here. I'm going to just make this a little bit smaller so we got space to see it. So here's the prompt, right? You are the host agent. You have the call. Things that you can do is to reason and remember, deconstruct and delegate, act as an orchestrator, not a doer. So you should be just sending tasks over to the sub-agents and not trying to do too much themselves, and then synthesize and respond. This is the roster, and this means what are the agents that are accessible to you. So the Notion agent and the ElevenLabs agent, and there's only going to be one tool, and this tool is called delegate task. And all this is going to be doing is that it takes the prompt from the user, determines what task to send to the agent and sends it to it. That's pretty much it. So here's an example flow, right? So if the user says, can you tell me how many sermon notes we have, and we need a title using text-to-speech, right? It's going to know that it has to work with the Notion agent to count the notes and then find the latest article or whatever. And then it has to use the ElevenLabs agent to convert it from text to speech. And that's pretty much what we need to do for the prompt. Okay. And so the next thing we can do is to do the agent. And this is going to be like one of the fastest and smallest agent. So I'm just going to paste the whole thing here. And this is going to be create host agent, right? And we make sure the root agent equals create host agent. And here it is, right? It's just the host agent orchestrator. We're going to use Gemini 2.0 Flash via LLM. And then the description is that it's just an orchestrator. And then we're using host prompt. And then we just need to define this delegate task sync tool, which I just described earlier. All right, we'll do that within tools. So let me show you how this is going to look. I'm just going to paste the code in, and then we can look at it in more detail. Okay, ignore the missing remote connections because that's what we need to do next. But effectively, it knows which agents it has based on the URL, and then it just delegates the task to an agent with a description. Okay, and the way that it does that is that it will use something called invoke agent with the task description, which we'll define shortly. And then the reason why we actually need to have a synchronous task here is that that's the only way that I've found that you can actually send an asynchronous task into an agent. And what it does is that it actually just use async IO to run it in loop, and then it just runs the delegate task with a certain timeout. Okay, so this is not that interesting. This is like a wrapper around the delegate task method. And that's all we need to do over here. And then finally, for remote connections, the way that it's doing for remote connections over here, I'm just going to paste it so we can walk through it. But ultimately, we are actually dealing with mainly the A2A SDK here, right? And we're determining how we're going to connect to our two clients. We're using the A2A client class here, which we use for our test clients, if you recall. And then the way that this works is that you can either create a connection to a client, close it, and then you can invoke a query against it. All right. And the way that it does it is it uses the A2A client to create the agent, and it sends the payload. And then there's a bunch of stuff here that we do to handle the responses. And then there's a lot of helper methods here that allows us to make sure that we pack and send the payload according to the A2A protocol and the way they expects it. Okay. There's a bunch of helper methods here, which isn't the most critical. So I won't go into too much detail, but effectively, this allows us to continuously work and hold a connection with the agents and then pull for and check for responses and then send it back when it's done. All right, so that's all done. We do need the main.py, and then we also need an agent executor as well. Actually, with all of these files that we have here, agent, prompt, remote connections, and the tools, we don't really need just yet to define main and agent executor. Why? We actually technically have enough for us to actually run the agent through the ADK without using A2A. And I'm going to demonstrate this to you via a UI that's included in the repository as well. But before I do that, I want to explain what I'm doing here and what I'm going to do next. Okay, so one way to actually use your host agent is what I call an embedded way of doing it. Okay, so what we're going to do now is that the host agent, which is in the ADK, we could actually embed it within a Streamlit application directly. This will allow us to effectively not have to use A2A. So what this means is that rather than using our UI and then hitting an endpoint, because we haven't actually exposed our agent via an endpoint yet, we can actually just bake the entire ADK into the Streamlit application because it's written in Python, right? So technically you can actually just kind of put it in memory and then let the Streamlit application front end just work directly with the agent with its own runner, which, if you recall, the runner is actually part of the ADK itself. And so we're actually going to do that first and then give this a roll. You will see over here that I have an app on the UI and then A2A app. Okay, so what we're going to try first is that we're going to use the app version without A2A. And you can see, right, what it does is that it directly in memory just uses the create host agent function, and then it stores it within the app itself. And then it then creates a runner, right, that runs the host agent in memory within the Streamlit app itself. So you don't have to deal with any A2A to the host agent, but it will still use A2A and remote connections to the sub-agents. But this is the quickest way to just test that everything's working, right? The downside of this is that the only way that somebody is going to be able to access your agent is via your predefined Streamlit application, right? You can't expose it with an endpoint. We haven't done that yet. And I'll show you how to do that in the next step. But let's test this out. Okay, let's just clear and clear. And I've got a very nifty script in here called start agents. And what you do is that you do Python scripts start agents. And what you want to do is node with host. All right. And then what's going to do is it's going to start both agents, A02 and A03 for the Notion ElevenLabs agent, but it will not start the host agent. Why? Because the host agent is not being served by an endpoint just yet. We haven't reached that step yet. So both agents are ready. Great. So now all you need to do is do Streamlit, run UI, and then you do app.py. Okay. And this is now going to create a Streamlit app that you can then run. And let's give this a whirl. So once you've loaded it up in your browser, you can see that we're ready to go. So you usually say, hi, what are you capable of? And I always like to do this just to make sure that the agent is running correctly. So you can see it's capable of delegating tasks to the Notion agent or ElevenLabs agent. So here's where you can actually do something really cool. So let's do a slightly more complex task just to make sure that it's actually working correctly. So we say, search my Notion workspace or the Sermon Notes database and show me the distribution count of sermons by speakers. Okay, so it's a fairly complex task. It's going to have to search workspace and then find a database that's called Sermon Notes and extract out the ID and then query it and then pull it up. But hey, check it out, it's done. I've got a distribution of sermons by speakers from the Sermon Notes database, and this is actually correct based on what I know about my database. And there's some debugging stuff here. You can see the tool call that we did was the delegate task, right? And then it delegated it to the Notion tool, and then this was the response. Now, what we're going to do now is that we're going to say, now please speak in audio the distribution that you just returned, summarized in a way that flows as a narrator. Okay, and so let's just give this a shot. So now the host agent is going to need to take the context of the conversation we just had, as well as the instruction and prompt, and determine that it needs to send this to the ElevenLabs agent. So this is the reason why we had to do all this session storing and the context storing and the task storing, so that it will be able to know when it sends the prompt, right? When it says the audio or the distribution here, you need to know that this refers to the previous conversation that we had about this distribution. And it's done it here now. I'm just going to pop into cursor, actually. And then I'm going to control click on this because I'm using Windows subsystem for Linux. So it's not easy to find the files like the specified path. Okay, let's see if this works.
Let me share the breakdown of sermons by each speaker. Paul Williams has delivered 4 sermons, while Phil Hudson has given 8. William Taylor and Gwilym Davies have each presented 7 sermons. George DeWalkar and Henry Edick Taylor have contributed 1 sermon each. Additionally, there are 15 sermons where no speaker has been assigned.
Great. So this is working, right? And it was pretty good. It actually took the distribution here and narrated in a manner that is very natural sounding. So now you actually have a host agent that's able to use 2 subagents and deliver results to the user using a combination of both. And hopefully this has shown you the power of using multi-agent architectures, utilizing subagents that are capable of tools, and then how you can combine them together. But remember what I told you before, that this approach here is embedding the host agent into a Streamlit application. You can deliver it like this, but what happens if you want to make your host agent itself A2A compatible? And that's what we're going to do next. So now let's move on to making our host agent A2A compatible. And using our cheat sheet again, right? All we need to do is define main and agent executor. And honestly, you will see it's almost exactly the same code to get this working, whether it's a worker agent or whether it's a host agent. Okay, the main file is what I'm going to do first. So main, and I'll drag this over here and move this aside, put this here. All right, this is going to be our main file. And let me just walk you through it. Okay, so same thing again, it just takes in a host and a pod, right? The skill that it has, it orchestrates workflow, sets up the agent card, create the host agent, the runner, and the executor, which we will define shortly, and then handle the request, start the Starlit application that is A2A compatible, and then serve the server. And that's pretty much it. And then for the agent executor, here's the code. And like I said, it's going to be very familiar again this time, right? We store the agent card and the runner, set up the services, and then we do the same pattern again. Prepare the input, get the identifiers and ensure that the session and context is there, and then run until we get the final message and send the response back to the client. And the same set of helper functions, pretty much with some tweaks just to make sure that it works correctly. And then we also had the cancel method. So now that you have this running here, we can actually run it pretty much the same way that we were running our agents previously. So I'm going to just close this for a second, and I'm going to kill the Streamlit application, and I'm going to stop this running of the agents. Now, using again the script that I have, but this time you run Python scripts start agents, and this will actually ensure that it starts both the Notion and ElevenLabs agent, but it'll also start your host agent. All right. And I'll just give it a second for this to run. All right. So now that these are all running, I am going to drop in the test client from the repository as well. And you can see it's pretty much the same. It uses the A2A client, that client from Agent Card URL, very similar to the others. And now you can interact with your host agent just like you would any other A2A agent. The test that I'm going to run is that it's going to run simple search, count the sermons. It's going to find sermon notes and read the titles of the first 2 entries aloud, and then it's going to convert it to speech. All right, so what you can do is the same thing, Python host agent / test client, and off we go. And this time, you wouldn't be able to see it running over here, but you can actually check the logs folder for how things are going. I've got this outputting to the logs folder because you're running 3 agents, so you won't be able to see it output in the terminal. But you can see, if you go to the standard error output, you can see it doing all the processing on the server side, which is a very useful thing when you're debugging your agents. And cool. So let's see, it was able to count the entries. Okay. And then it's doing the thing. It's going to read the first 2 entries aloud, which I think should be fine. Okay, over here. I hope I have enough credits in my ElevenLabs account. Yep, so it's done it. So it says I converted text to speech. So it's over here, which I suppose we can actually pull up.
This is a test of the text-to-speech system.
Cool. All right. So all the tests have passed, right? And yeah, so you can see the first 2 entries here. And this is the interesting one, right? This is the combination of both MCP servers, right? The titles of the first 2 entries are Knowing the Heart of God, Real Repentance, and Knowing the Heart of God, Unbreakable Love. And it's converted it to speech here. So let's just play it.
Knowing the Heart of God, Real Repentance. Knowing the Heart of God, Unbreakable Love.
There you go. So it's working now, and we can be confident that our host agent is actually working correctly. And so the final thing that we can do is I've actually included yet another Streamlit application called A2A App. But the difference in this one is that rather than embedding the host agent into the memory, it's actually going to be interfacing with our host agent, just like it did with the other agents, via the endpoints. And this is a powerful demonstration because now you can actually replace this endpoint using React, TypeScript, or Next, and you just configure your own front end now, and you can know that you can interface with your agent via the endpoints, and it will work pretty much the same as the previous one, but this time there's no embedded agents that are going to be running. So we're going to give this a quick whirl now. So the Streamlit run, and it's UI A2A App, and then once this loads up, we will go into the browser and just check it out. Now, it's going to be very similar to the one that we were doing before, but the difference here is that we are actually connecting to the host agent via A2A and using endpoints. Okay, so you can see it's actually connecting to this rather than embedding the host agent within the Streamlit application itself. All right, so we can say, hi, what, view, and move off. And it's going to do its thinking. And so it's going to be able to delegate tasks. So very similar to what we saw last time. And so check my date Notion workspace for the cellular nodes database. And then give me a distribution of number of sellers by months. Then, and so you can see it's actually using the request is being sent to the agent via HTTP request. And here you go. So here's the distribution by month, which is great. And then it says some entries do not have service dates, so they're not included. And then finally, summarize which month had the highest number and which month the lowest, and narrate it back with speech in the style of a newscaster. In this case, it's going to once again use the Notion agent. And like I said, the context and the session is very important because when we say summarize which month had the highest number, it will know that it's talking about the months that it returned in the distribution before. And if you didn't set this up correctly, what happens is that it'll be like, what are you talking about? What do you mean by month? And you will see that it's actually quite important to make sure that this is set up correctly. Cool. All right. And it's saying the file over here. The terminal here. Let's pop this here, click here. and play it within Cursor.
In the Sermon Notes database, September 2024 and May 2024 tie for the month with the highest number of sermons, with 5 entries each. Several months share the distinction of having the lowest number of sermons, with 2 entries each in June 2025, April 2025, March 2024, November 20.
Well, you get the idea. I guess maybe that wasn't the best example to use for speech because it ends up being pretty long. But as you can see, the host agent is working correctly. It's able to communicate with the front end. You can actually look at some of the debug output that I have here because I was actually debugging this for quite a while to make sure that it worked correctly. And all this code is all included in the repository. And so this brings us to the end of our lesson. So quick recap of what we've actually managed to do over here is that we looked at how an ADK agent can be set up very quickly together with A2A. We looked at the difference between running it with the ADK via the endpoints via A2A. And then finally, what we just did is that we actually showed that the Streamlit application can actually be interacting with the agents via HTTP requests, or you can have a directly embedded Python agent within the Streamlit application itself. So this brings us right to the end. I really hope that you found this crash course tutorial helpful. I know for me that given that the ADK is being developed so rapidly and things are changing so fast, I wasn't able to find something that kind of wrapped everything together. So hopefully this is a good resource for those of you who are trying to figure out how to build agents with the ADK and making them A2A compliant and obviously interacting with MCP. As I mentioned, the source code for this entire project is entirely free. It's on my GitHub. However, I do have a slightly more beefed up version of this, which includes the cheat sheet that you see over here that helps to summarize the key takeaways from this. The other thing that it includes as well is actually the lesson plan that allows you to really step by step around everything that we did in this tutorial, which sometimes is very useful to be able to have something to glance at and to read very quickly. The other thing that this will include is also, if you recall, we were running the tests manually by ourselves. And one of the things that I have included as part of the agent builder pack, an entire pytest suite. So I'm just going to pop this over here so you can see it. But the idea is that with this, you don't actually have to manually run your tests. What it does is that it actually uses pytest, which is testing framework that Python supports. It actually allows you to run this test automatically and uses the testing syntax and you set up things like fixtures if you know what those are about. And the idea is that you want to have these tests because when you're building applications, you want to be able to continually test them in your continuous integration or continuous delivery systems as well. So you can put this in with GitHub Actions. Finally, one of the things that I'm also including as part of the builder pack is actually something called cursor rules. So if you aren't familiar with cursor rules, they are actually rules that enable the cursor to make more informed decisions about the code that it supplies and the kind of changes that it makes. And I've actually created 5 of these rules here that really helps to guide agents like Cursor to be able to build with the ADK with much more precision. It overcomes some of the lack of documentation because this is a very new thing. I'll just show you a couple of them here. For example, the architecture of creating an ADK agent, you always have to have a root agent. You use create my agent, and then you have the init. And these are things that it's quite easy to miss, even if you just look at the documentation and you might miss it and it might be things that trip you up. And so the idea behind this is that behind the builder pack is to not to just provide information, but allow you to take the repository to the next level. You can use it to build your own agents, configure, completely redesign everything. And it also includes, for example, here how you would use the ADK with the UI like Streamlit and how you use it with the A2A rather than the ADK. All of this will be made available in the build pack. And like I said, it is a paid package. You don't need it to follow with this entire tutorial at all. It's just some nice bonus extras if you want to take your agent development to the next level. And if you are part of the insiders group, you would have received an email with a coupon that will allow you to claim the entire builder pack entirely free. And that's just my way of saying thank you for the supporters and people that have been engaged so far, and hopefully you find it useful. That's it. I know this was a slightly longer tutorial, but I hope that you've managed to get the information out of it, and I look forward to seeing you next time. Please do let me know if there's anything you'd like to see related to ADK, A2A, or MCP servers. I do get a lot of questions, and I do try to incorporate all of them into my subsequent tutorials and how I formulate the tutorials so that I answer as many of these as possible. Don't forget to give this video a like, subscribe, and hit that notification button so that you get notified when new videos get released. If you haven't already checked out the rest of the ADK Made Simple playlist, you might want to check this out right here. And if you're actually interested in something else, such as game development, I've actually got a playlist related to building games and coding games over here as well. I really enjoyed recording this episode. I hope you enjoyed it too. And till next time, see ya.